All right, so what I want to do right now is I do want to talk to you a little bit about this coronavirus and about the variants, about the spike proteins, about the antibodies, because I am getting this question a lot in practice with patients that I'm seeing. So this is a question that I've heard or thoughts about this concept numerous times. So I thought it would be a good place to begin to discuss this a little bit. So first, I want you to understand many people have often asked or stated that, an argument about should I get vaccinated, not get vaccinated, how's a vaccination going to deal with a virus? Because they'll say that a virus is not living, right? A lot of people argue that a virus is not living. All right. And that is arguably true because a virus does not reproduce. It replicates, but it does not reproduce. Bacteria reproduce, right? So it's argued that a virus from that language is not actually living entity. So how could the immune system react to the virus, right? And so my clarification is what your immune system reacts to are proteins. They could be food proteins, they could be proteins from the environment, right? And they can even be your own self-protein, self-tissue, which is what autoimmunity is, right? But your immune system reacts to proteins. Now, what does the virus have? What does the virus use to get inside your cells? It uses what's called spike proteins. There it is. It's a spike protein. So what the immune system reacts to is not the virus per se, it reacts to the spike proteins. Now, what are the spike proteins? The protein is what the virus is using to lock onto a protein receptor on a cell. And these cells are mostly in the lungs and in the digestive tract. So that's the primary entrance for the virus, through the lungs and through the GI system by the protein locking onto these specific receptors. When it locks onto the receptor, then the virus can enter inside your cell. That's the first thing. Another argument people make about the messenger RNA vaccination specifically is their concern is, I don't know, is this thing going to screw up my genes? I don't know anything about this yet, and I don't trust that the messenger is not going to get to my genes and manipulate my genes. When we discussed in the past, it doesn't because it only hangs around for a really short period of time and it disintegrates. Basically, it's attacked by enzymes, right? It's just information, okay? Um, but but my point is what is the virus doing? The virus, when it comes inside your cell, right, it integrates itself with your DNA. That's what it's actually doing, right? And then it's reconfiguring the DNA and using your DNA to replicate itself. So it's replicating itself 1,000-fold inside your cells to the point that your cells can't hold the virus. And the cell bursts open and it releases tens of thousands of viruses that now can quickly infiltrate with those protein receptors other cells. And that's the spreading of it. So again, if you get the virus, it's manipulating your genes. That's the first thing, right? But the messenger RNA is giving instructions. It's an instruction sheet. So your genes, your DNA takes that instruction and your genes make proteins. So it's telling your genes to make the spike protein, the exact same spike protein that the virus is using. So this way, your genes make this protein. When enough of these proteins are made, they are expressed on the surface of the cell, and your immune system sees that and says that's different. That's something I haven't seen it before. So your immune system manufactures antibodies intentionally against these made spike proteins. So what's happening is now you have the antibodies targeted specifically to these proteins. So if in the future you get exposed to the virus and the virus gets access and it actually comes in, these antibodies are or have already been produced. They're already there. And they can then lock on to those protein, the spike proteins and neutralize them. So what that does is it limits the virus from locking onto your cell. So the virus can't get into your cell and start replicating. That is the purpose of making these antibodies. It happens naturally if you get the infection, but the intention of the vaccination, specifically the messenger RNA, is to manufacture those proteins. That is what the intention is. Okay. I'm not going to get into this part because I did explain to you the differences about the antibodies and how they're made. If you get the infection, the antibodies are made a little bit differently. They're made outside the germinal center of the plasma cell that makes the antibodies. A little unusual because usually the antibodies are made inside the plasma cell. So the infection, they're made outside the plasma cell. And that's seemingly been associated with a higher risk of those antibodies cross-reacting with self-tissue, which is why post-COVID, there seems to be an explosion of autoimmunity triggered by that cross-reactivity. The antibodies that are made intentionally by the vaccination, it's been shown those antibodies are being made inside the plasma cell, so they're more specific, and there's less cross-reaction with self-tissue. It's kind of a better scenario. Okay, next part of the equation. What are we dealing with now? We're dealing with a variant. In fact, we're dealing with two variants. So the first variant began in India, and now there's the second wave of it now, the Delta variant, right? It gets spread through Europe, and now into the United States is the Delta variant. So what does that actually mean? So it means the variant or the change, the mutation is happening on the spike protein, right? So the variant, the change is how the virus can get into your cell. So there has been, I think, there's been like on that spike protein, there's been shown to be 8 mutations, 2 of them specific to how it binds onto the cell's receptor. So what does that mean for people that have been vaccinated? What does that mean for people that have gotten the virus in the past, right? So yes, there still is some protection there. Excuse me. There still is some protection there, right? But to what degree? So I think that some of the studies are showing us now that it's like in people that have been vaccinated, fully vaccinated, that they are having about 50% of the antibodies able to bind to the spike protein. But the variation is enough that there still is plausible entry inside the cell. So it's not a foolproof, right? If a person got the infection and they got the infection early on, right, the studies are showing us that the antibody count probably diminished over the course of the year. And so those antibody counts are going to be low, and they're going to still be at a higher risk for, again, infection from the variant. So there is no foolproof because of the variant now, right? And so the problem with the variant is because it's been taking so long for people to either get infected or to get vaccinated, is that there's still a lot of people, 50% of the country that is not vaccinated, okay, or fully vaccinated. So those people, get infected even if they have mild symptoms and still allow the virus to mutate. So that's why it was an exercise in speed, right? So the longer it's taking people to have, immunity, whether from an infection or from the vaccination, right, it's giving the virus more time to mutate, right? And the new mutation, the virus is becoming more stealth. It's becoming stronger. It's becoming more aggressive, right? It's able to spread faster. It's able to enter and replicate faster. So it's a stronger variation than the original virus we faced a year or so, year and a half ago, unfortunately, right? So it still stands to reason, in my opinion, that you still have the upper hand, right, if you are fully vaccinated. That's why I personally chose to get vaccinated. Now, I'm not, people who don't want to get vaccinated, that's fine. I'm just here to present information, right? And that's, in some of it's my opinion, obviously, but that's the world that we're living in. So so I want you to understand again that um, the antibodies are intended to block the spike protein that the cell uses to enter inside your cell. Now, what does that got to do with spreadability? I've heard a lot of misconceptions on that too. In fact, someone yesterday was saying, and I had to say, no, that's not correct, right? If a person is vaccinated, do they spread it as easily? Well, what it is that if a person is vaccinated, fully vaccinated, right? And their immune system is healthy and robust. That's the other part, right? Is they have the antibodies to lock on to those spike proteins so they can't enter. So it diminishes what we call the viral load. So the viral load, the amount, the quantity of those viruses is going to be less because their immune system is more robust, right? And they can clear the virus out. So they're carrying less. If they're carrying less, there's less to spread, right? When people get infected, the virus is replicating. There's a higher volume of viruses, right? A higher viral load. Higher viral load, there's more viruses to spread. That's why when people are not vaccinated and they're infected, their viral load is through the roof. They can spread it to a lot more people quickly. So if they're spreading the variant, even people who are vaccinated can pick up the variant and become infected. And you're seeing it. And you're seeing these ball players who've been vaccinated now are getting COVID because they're probably getting the variant, right? So the vaccination, if you're vaccinated, the intention is not to, it's that you can still get infected, but the real goal is to diminish the exaggerated immune response, right? So it's really to diminish the symptoms so the symptoms aren't as severe, right? And you don't get all the severe complications from the infection, but you can still transmit this.